Hi, this is Dr. Maria Weber. This week, my astronomy class is learning a little bit more about our solar system. And in particular, I wanted to make a video to talk more about Saturn's defining feature, its rings, which we see behind me here. It always amazes me when I think about Saturn's rings, how really thin they are compared to their width. Now, the main band of Saturn's rings extends from about 30,000 kilometers above its atmosphere to twice that of Saturn's radius away from its surface or from its upper atmosphere. Now, the thickness of these rings is just a few hundred meters in comparison to its hundreds of thousands of kilometers in width. Now, these rings are not solid, but they're made up of a swarm of individual bodies. You can think of them as a swarm of anything ranging from the size of a grain of sand or a pebble all the way up to as large boulders as large as the size of houses. And the composition of these rings is made mostly of water, ice, and carbon compounds. Now, most of Saturn's rings are within something called its Roche limit. Now, the Roche limit is the point around a planet at which the tidal forces from that planet become strong enough to tidally disrupt a gravitationally bound object. Now, within the Roche limit, an object that is held together by gravity is torn apart into smaller pieces. So typically, the Roche limit of a planet is about 2.4 times the planet's radius away from the planet's center if the moon that we're thinking about, or the object that we're thinking about that's being ripped apart, has about the same density as that of the planet. So if you're a moon orbiting a planet and you're far enough away outside of the Roche limit, then you're not going to get torn apart by the planet's gravitational pull. But if you get too close and you pass within the Roche limit, inside the Roche limit around that planet, then the gravitational forces from that planet are so strong that they can actually rip that planet apart into smaller pieces, creating those beautiful rings that we see around Saturn and some of the other gas giant planets as well. Now, here's an example of the rings around our Jupiter, Saturn, Uranus, and Neptune, our gas giants. On this vertical axis here, we have the distance from the center of a planet as a multiple of that planet's radius. And so we can see that Jupiter does have some set of rings. And we have Saturn has many different ring sets. And we have Uranus with some rings here, a number of different rings, although they're fairly small in their extent. And then Neptune also has a fine set of rings. Now, here's a little bit more about Saturn's rings. And in particular, here we see Saturn's moon Daphnis, which is a very small moon. It's orbiting inside the Roche limit, but it's a small moon. And it sweeps out a gap in Saturn's rings, and it can actually distort the rings here. So here we have Daphnis moving within this gap, and its gravitational forces are actually causing ripples to appear inside the ring here. And also, Saturn has a tilt of about 27 degrees, and our Earth has a tilt of about 23.5 degrees. And it takes Saturn about 29 years to go around the sun once. Because of our Earth's relative position compared to Saturn during Saturn's about 30-year orbit, as Saturn moves around within the solar system, we see its rings from different perspectives over the course of that 30 years or 29 years. So right now in 2020, this is sort of the view that we have here of Saturn's rings. We can see them kind of tilted from the edge, so we get a good view of them. But over the course of the next few years, Saturn's going to be changing its orientation of its rings with respect to us. And when we reach 2024 or 2025, we're going to be looking head on down the edge of Saturn's rings. And remember how thin they are, just a few hundred kilometers in compared to their size, or a few hundred meters in comparison to its width. We're looking down the edge of Saturn's rings, and so it's going to be really hard for us to see Saturn's rings during those few years from telescopes here on the Earth. So a really great time to be catching Saturn's rings is going to be now over the course of the next few years until we approach about 2024, 2025, 2026 even, when we're not going to see as much of those rings as we can right now.
Now before we leave, let's go ahead and calculate the Roche limit for Saturn. Now this is an equation that we can use to find the Roche limit. So d will be our Roche limit, the distance away from the center of a planet, where if you get too closer than that distance, then you start to become ripped apart by the planet's gravitational pull. So that distance is equal to 2.4 times the radius of the planet times the density of that planet divided by the density of some smaller body that's trying to get a little bit too close, and you take the fraction of those densities to the power of 1/3. So let's use values for Saturn then. We've got 2.4 times the radius of Saturn is about 58,000 kilometers, so that's 5.8 times 10 to the 4 kilometers. And we're going to multiply that by this density fraction. So the density of Saturn is near 0.7 grams per centimeter cubed. And the density of, let's say, one of Saturn's moons are pretty icy, and the density of ice is near about 1.2 grams per centimeter cubed. And we would take that all to the power of 1/3. Okay? So in your calculator, I would suggest that you take this fraction first, 0.7, and divide it by 1.2, and then you raise all of that to the power of 1 divided by 3. Or you could raise it to the power of 0.33. That's okay too. That's pretty close to 1/3. And then you multiply that by 5.8 times 10 to the 4 times 2.4 in order to get you the Roche limit for Saturn. Now, if we look at the units here, we have the units of density canceling on top and bottom with each other. And so then our answer is just going to be left in units of kilometers. So when I do this calculation, I find that the Roche limit for Saturn is 1.16 times 10 to the 5 kilometers. That's also 116,000 kilometers. Okay? So if you get closer to Saturn's interior than this number, 116,000 kilometers, then the gravitational pull of Saturn will start to pull you apart. Now, the majority of Saturn's ring system lies within this Roche limit, which makes sense, as if an object gets too close, it's going to be ripped apart by Saturn's gravitational pull. So Saturn's rings range anywhere from about 66,000 kilometers to 480,000 kilometers away from the planet's center, but the majority of those big, beautiful rings that we see when we observe Saturn are closer to Saturn than its Roche limit of about this value right here. So for one of your problems in your lecture quiz this week, you are going to be using this equation right here in order to find the Roche limit for our Earth-Moon system.